This is our second experiment of open-ended experiment, which is Schmidt rebound hardness test. For the introduction, Schmidt rebound hardness test is carried to determine the rebound hardness of test materials, particularly rock, by using the Schmidt impact hammer. With its portable, simple, and affordable attributes, the Schmidt hammer SH is an ideal index apparatus which underlies its increasing popularity and expanding range of application. The SH rebound hardness value is perhaps the most frequently used index in rod mechanics practice for estimating the uniaxial compressive strength UCS and the modulus of elasticity of intact rod both in laboratory condition and in situ. The SH is also widely used for estimating the UCS of discontinuity walls and assessing the workability, excavatability, and borability of rock by mechanical means cutting, polishing, milling, crushing, and fragmentation process in quarrying, drilling, and tunneling. The device is portable and may be used both in the laboratory and field. This is the figure of 2G4-1 working principle of a Schmidt ham. Thank you.
The objective of the experiment is to determine the hardness and uniaxial compressive strength UCS of rock. Next, the theory of the experiment. When operating the Schmidt hammer, shown in figure 1, a constant amount of stored spring energy is imparted through a hammer mass to the plunger, causing the mass to rebound a distance proportional to the total energy absorbed by the impact surface. The rebound index is shown by the indicator and is defined as the rebound index. The degree of rebound varies depending upon rock elastic property. The height of rebound of mass is measured on a scale and is taken as the measure of hardness.
Before start the experiment, rebound hammer should be tested first. After that, press the plunger to the sample of the rock and make sure the rebound hammer is perpendicular to the sample test surface, and then record the data.
Next, we will proceed with calculation for Schmidt rebound hardness test. So based on the data given, there are 20 readings of rebound number. In this experiment, we are required to obtain a UCS value. This can be done by using the graph over here. So the x-axis represents rebound number while y-axis represents UCS value. As an example, for number 1, the rebound value is 40. On the graph, draw a vertical line at 40 on the scale until it touches or intersects with 26 line. We use 26 because the sample that is used in this test is granite. So from the intersection, draw a horizontal line until it touches y-axis, and there you have it, UCS value for rebound number 40, and the same goes to other rebound number. After completing our reading, UCS value for all rebound number obtained. Then, we need to calculate the average of rebound number by summing all the rebound number given and divided by 20. The same goes for UCS value. We need to find the average. The steps are the same, sum everything and divide it by 20. As the result, average rebound number is 41 approximately, and average UCS value is 95.8 megapascal.
Okay, so next we will move on to the discussion of G4 experiment 2. So from the experiment and calculation that we have done just now, we can find that average rebound value is 41 and the average compressive strength is 95.8. So based on the theory of this experiment, the rebound of an elastic mass depends on the hardness of the surface, and it also means that the higher the rebound number, the higher the UCS value of the rock, and it also means that the rock has the better quality. So according to the table in Geological Society that we have put in the left top corner, we can find that it is a strong rock since the average UCS value is in between 50 to 100 megapascal. So it can be described as low-grade metamorphic rocks, marbles, and some strongly cemented sedimentary rocks. So that's all for our discussion.
In conclusion, we have completed the objective of the experiment, which is to determine the hardness and unaxial compressive strength UCS of rock. We also get the average rebound values and UCS, which is 41.1 and 81.75 MPa. Therefore, we can classify the granite as a strong rock.